Recursion is the process in which a function calls itself. A classic example that is used to demonstrate recursion is the factorial. We know that the factorial of an integer is the product of that integer and all of the integers below it. So for example, if you want to know what the factorial of 3 is, it would be 3 times 2 times 1. The factorial of 5 is 5 times 4 times 3 times 2 times 1. So you get the idea. Here we have the factorial function and it takes n as input. And we say that if n equals 1, then return 1. And otherwise return n times factorial of n minus 1. So at this point, it calls itself, but this time with n minus 1. And that's why it's called a recursive function, because it keeps calling itself. Let's start with a simple example. So here we have the function, and then we're calling this factorial function and passing number 3 as input. So we want to calculate the factorial of number 3. And we know that it would be 3 times 2 times 1. So let's see what this function does. We are passing 3. It checks to see if n equals 1. It's not, because at the moment it's 3, so it doesn't do this. It goes on to the else, and it returns n, which is 3, times factorial of n minus 1. So at this point, we are calling this function again. N minus 1 is 2, so it's going to call this function with 2 this time. 2 is not equal to 1, so it's not going to do this. So it's going to go in here, and it's going to do 2 times factorial of n minus 1, which is 1. So this time it's going to call it with number 1. N is equal to 1, so it will return 1. So let's break down the steps with our factorial 3 example to see what happens. So we know that factorial 3 will say 3 times factorial 2, and so factorial 2 will say 2 times factorial 1, and we know that factorial 1 is simply 1. So we then work backwards. We know that the factorial of 1 is 1. So this line is going to be 1 times 2, which is 2. And then we know that the factorial of 2 is simply 2. So this line is going to be 2 times 3. So the result is going to be 6.